This question is kind of having us unravel the definition of an instantaneous slope, the definition of the derivative at a point. It looks like this notation down here, right? Where a is 13. You can get that from here. And f of x, I probably should have started with f of x. The function f of x, sorry, it's down here. The function f of x, we're doing a plus h. So when you think about this notation, this is saying that you're plugging a plus h in for x in the original function. So if we do the fourth root, then a plus h, if we plug in 13 plus h right in here, it matches what we have over here. So that means we've got the right function. So this is one where you can play around, you can make a guess, check your work, see if you were to plug this into the definition of the slope at an instant, limit definition of the derivative, they should match up. And I don't know, I guess that's it for this one. We've identified f of x and identified a. Okay, so they give us a function. We're supposed to write a limit representing the derivative at x equals 1. So this one, they have us set it up for the second limit notation, the one with h that we just saw. So that means, well, we need our fraction first. And the top, I need a cube root. So there's a button that lets me put a 3 for a cube root, and now it's 8, and then it's we're centered at 1, so I'm going to plug in h plus 1, and then there's another plus 1 on the outside, because remember, with this definition, it's, I don't know if I have it on the other screen, I might. It's this one down here. We're plugging in a plus h, the value we're trying to find a limit for. We're plugging a plus h in for x in the function. And then we're supposed to subtract that by f of a. I wonder if they want the actual number. So we're supposed to subtract that by what happens if you plug in 1. 8 times 1 makes 8. 8 plus 1 makes 9. And we need the cube root of 9. Let's see if it just lets us do that. So cube root of 9. And the denominator is h, because h is the thing that's getting infinitely close to 0. Okay, yeah, looks like they're okay with that notation. They did 3 to the 2/3 power. You don't need to do that.